So this worksheet is really great practice to kind of bring together some of the things we've talked about in chapter 7 and 8. So we're going to run through one of them, and then I'm going to skip down to vitamin B to show y'all some kind of how I suggest approaching a big molecule like that, and then you'll have the answers to check yourselves on correctness. So this is acetic acid. Now we're wanting to count sigma, pi bonds, and then talk about bond angles and hybridization. But the first thing is that this structure is not complete. So we're going to go ahead and add in our double bonds and our lone pairs. So now everything else looks like it's okay. So first thing I'm going to do is count pi bonds, counting my single bonds. So when I do this, I usually will cross them out. I'll do 1, 2, 3, 4, 5, 6, 7. That way I don't miss anything. And then with double bonds, it's usually a little bit easier because with pi bonds, it's a little bit easier because you can see the darkness of that double bond. So there's one pi bond. Now this says to do the atom 1, 2, and 3, and we're going to do the bond angle and the hybridization. So for atom number 1, right here, it's going to be sp2 hybridized. It has sp2. So remember, those lone pairs count just like they would bonds. And we're going to predict the bond angle is going to be 120 based on sp2 hybridization. Atom number 2 is this other oxygen. It's going to have a hybridization of sp3. And so we're going to predict that this is going to have 109.5. The last one is atom number 3. So this is going to be sp2 hybridized. And we're going to predict a bond of 120. So identify the hybridization. Remember that each lone pair, each bond, each double bond, each multiple bond, they're going to count only as one. So just because there's a double bond doesn't mean it counts for more than one. All right, so you'll practice with acetylonitrile and caffeine. Let's see if I can erase the highlighting. There we go. All right. And so let's go down to vitamin B. So this one says the last one is to count how many sigma and pi bonds there are total. All of the bonds are written in here. It's just the lone pairs that are not. So the first thing it says is how many carbons are sp3 hybridized. So we're looking for carbon to have 4 things around it when we're looking at sp3 hybridized. So I see 1, 2, 3, 4, 5, 6, 7, 8. So I see 8 that are sp3 hybridized. If it's going to be sp2 hybridized, it's going to have 3 things on it. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I've crossed all of my carbons out, which means there aren't going to be any sp hybridized. So I'm going to erase all those so I can see. The next one is going to be nitrogens that are sp3 hybridized. So this is going to be nitrogen with 4 things around it. We don't typically see that because nitrogen with 4 things around it is probably going to have a plus charge. Or it's going to have this in a lone pair. Okay, so we have to look really carefully because these lone pairs aren't shown. So at this point it might be a good idea to write in the lone pairs. So now I can see that I'm going to have 1, 2 sp3 hybridized. When I look at sp2, this is going to be most likely this arrangement right here, and I know now that I have 2 of those. And then there aren't going to be any of the sp hybridized. This would be a nitrogen that's triple bonded. The next one is oxygen. So we have a little more oxygens than we did nitrogens, but not as many as we had carbons. So when we're looking at sp3 hybridized, we're looking at 4 things. And so I can see 1, 2, 3, 4 that are sp3 hybridized. sp2 is going to have 3 things attached, so my other 2 oxygens are going to be sp2 hybridized, and I'm going to have no sp hybridized. Okay, so now I've taken into account all of my counting, and now I need to do how many sigma and pi bonds there are total, and this is where I'm going to use my trick of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52. So before I forget that, I'll write it down, and then I go back through and make sure I got all of mine. So I wrote the number 23 down just in case I lost count or messed up. I could always come back to 23 and start there at 24. As far as pi bonds, I'm going to have 1, 2, 3, 4, 5, 6, 7 pi bonds. And we don't need to worry about which of the 3 rings is planar. It's not something, you might cover that in organic chemistry, but not in this class. And then this last one, you're going to practice drawing the acetate ion with hybridization, resonance forms, sigma pi bonds. It's a great review of chapter 7 and 8.